Use a truth table to determine whether the argument is valid or invalid. And then we have the following statements: not P or Q, and not P implies Q. Then we have a second premise P, and then that's going to imply Q. The validity of this particular statement is going to be dependent upon the following validity of the conditional statement that we need to set up. So first, let's talk about this. This is going to be premise 1. And we're going to use that in order to set up our statement. And so we'll just simply go ahead and enclose in brackets, and then we'll write this first statement, premise 1, which, as I said, open parentheses, we have not P or Q, close parentheses, and not P implies Q. Then we're going to go ahead and look at the next premise. This is going to be premise 2 right here. Premise 2 is simply Q, and in this particular case, the way the true statement, or I should say the conditional statement, will be set up, this will be and P, and then we'll close that in, or close the brackets around this, and that's going to imply this last part, which is the conclusion. So this implies our conclusion of Q. So now we want to set up a truth table based upon this particular conditional statement. And we'll start with the first two columns being P and Q. So now we're just going to simply determine what the truth values of each one of these are going to be. For P, we can write true, true, false, false, and then over here, P can be true and Q could be true. P could be true, Q could be false. P could be false, Q could be true. P could be false, Q could be false. And now we have established the first two columns in our truth table. Now, since there is a not P in there, we're going to go ahead and do a not P column. And that would be our next column. And that would go right here. And that's going to be based upon the truth of our original P column. Since P is true to start with, that means that not P would be false. True here, it would also be false. False right here would be true here, and likewise true again here. And now we can go ahead and establish our first column containing one of our... Now remember that this symbol right here, as I have already said, is a not. This is also what we call a negation. And we're going to look at this symbol here, which is in English terms or, but it is what we call a disjunction. As I said, this is a disjunction. And then the following symbol means conjunction. And that in English would be an and. And then we would use this right here. That simply means implies. And it can also be stated as a then, as in if then. So we're going to use these to go ahead and build our truth table. Now, we need to go ahead and discuss this first combination right here, which is not P or Q. Now, when we're looking at not P or Q, for an or statement, that means one or the other or both will be true in order to make this or statement a true statement. So we're going to look at not P, which is false right here, and Q, which is true, so this would be true. We'll look at not P, right here, which is false, and Q, which is false, so this would be false. In this statement right here, or this part right here, we're going to have a true and a true, so this would be true. And then we have true for not P, and then we have false for Q, so this would also be true. Now we need to go ahead and discuss this next statement right here, not P implies Q. Now for this one, you have to remember that for not P implies Q is going to be true when the antecedent, which is this first part right here, is false. Okay? It's also going to be true if the consequent, which is the second one, is true. Okay? Now, if the antecedent is true and the consequent is false, then this will be a false statement. So not P, we'll look right here, this says false, and Q, this is true. So not P is false. Does that imply that Q is true? Now remember, if the consequent is true, this is automatically a true statement. Now here we have not P being false and not Q being false. And if the antecedent, which is the first one, is false, then this is automatically true. If both are true, not P and not Q, then this statement, not P implies Q, would be true. However, in this case, if the antecedent is true and the consequent is false, then this will be a false statement. Now we need to go ahead and discuss what happens when we put both of them together. Now this is going to be a conjunction, and that's what this middle symbol means. In order for a conjunction to be true, both of them have to be true. If either one of the statements, this one or this one, are false, then the whole statement will be false. So we'll look at not P and Q, which is the first one. This is true, and this is true for not P implies Q, so this will be true. We see that it's false because for this next statement, because not P and Q, or Q, is false, and this one is true for not P implies Q, so this will be a false statement. Once again, they're both true here, so then this will be a true statement. And then right here, they are true, and one is true and one is false, so this will be a false statement. And so we need to look at this entire statement here, and we then need to work with the and P. So we know that this statement here is true, and then P is true, so it is all true. This part is false. This part is true, so since both of them are not true, this will be a false statement. This one is true. This one is false, so this will be false. This is false. This is false, so they'll both be false. And now we have this column as true, false, false, false. And then we're going to need to look at this column in relationship to the implies Q right here. Okay, so now this last statement is going to be this whole thing, and it is going to be implying Q. Now remember, a statement implying another statement is false only when the first statement is true and the second statement is false. So in this case, the first statement is true, and we'll go way back over here. The second statement is true, therefore it would be true. The first statement is false. The second statement is false, so this will be true. The first statement is false. Second statement is true, that means it's a true statement. And this first statement is false, and the last statement is false, so this will also be true. And since all four of these are true, this is a tautology.